Imagine this for a second. You're walking through a forest deep in the night, and you see these tiny, shimmering lights just dancing in the air. Or picture diving into the ocean, down into the pitch black, where these ghostly, glowing shapes just drift by. It sounds like something out of a sci-fi movie, right? Well, it is 100% real. What you're looking at here, in this amazing jellyfish and this shrimp, is life that literally creates its own light. There's a scientific name for it, of course, bioluminescence. Bio means life, lumen means light. Pretty much living light. And it's honestly one of the coolest things in all of nature. So let's break that down. At its heart, bioluminescence is just light that's made by a chemical reaction inside a living creature. Now, on land, it's actually kind of rare. You've got fireflies, some weird glowing fungi, but in the ocean, oh, it's a completely different story. It is everywhere. From tiny little bacteria all the way up to giant squid, the ocean is just full of things that glow. Okay, so that brings up the big question, right? How in the world do they do it? How does a fish or a jellyfish just switch on a light? There's no plug, there's no fire. Well, it all boils down to some really, really special chemistry. And what's so wild about it is that scientists call it cold light. Now, if you've ever touched a classic light bulb, you know it gets super hot, right? That's a ton of wasted energy. Bioluminescence is the complete opposite. It's incredibly efficient. Almost all of the energy in the reaction becomes light, not heat. The actual recipe for this light is surprisingly straightforward. You basically need two key ingredients. First, you've got a molecule called luciferin. You can think of that as the fuel. Then, you need an enzyme called luciferase. That's the spark plug, the thing that gets the reaction going. You just add a little oxygen to the mix and voila, you get light. Whoa, okay. I know this diagram looks a little intense, but don't worry about all the little details. All this is really showing is that basic recipe we just talked about. You can see the luciferin enzyme helping oxygen connect with the luciferin, and that's what creates the flash. The most important thing here is that the enzyme, that spark plug, it's reusable. It can kick off the reaction again and again, as long as there's fuel. All right, so we've got the how covered. But now for the why, and this is where it gets really fun. See, in nature, you don't evolve a complex skill like this just because it looks pretty. This glowing is all about survival. It serves critical life or death purposes. And this quote really hits the nail on the head. Just try to imagine being in the deep sea. It's completely dark, sunlight is a distant memory, and there's nowhere to hide. In a world of permanent night, being able to make your own light isn't just a neat trick, it's a superpower. Let's start with a classic, using light for hunting. This is the anglerfish. It's got its own built-in fishing rod with a glowing lure that just dangles there in the dark. To a small fish, that little light looks like a potential meal, so it swims closer to investigate and chomp. In an instant, it becomes the meal. Okay, how about for defense? This is wild. Some shrimp have this incredible escape plan. When a predator gets too close, they can actually vomit a cloud of glowing goo. It acts like a flashbang, totally stunning the attacker for a moment. And in that one moment of confusion, the shrimp makes its getaway into the dark. But this might be the most brilliant defense of all. It's called the burglar alarm. When this Atolla jellyfish is attacked, it doesn't try to run. It does the opposite. It lights up like a firework, sending out these bright, flashing rings. The goal isn't to scare the attacker, it's to attract something even bigger. It's basically screaming for help, hoping a larger predator will show up and eat the thing that's trying to eat it. Genius, right? So we've seen light used to attract attention and to create a distraction. But what if you could use light to become invisible? It sounds completely backwards, but it's a real strategy called counter-illumination, and it's absolutely mind-blowing. Okay, put yourself in the fins of a predator, deep in the ocean's twilight zone. You're looking up, trying to spot the dark shapes of prey against the faint sunlight filtering down from above. Well, creatures like this squid have evolved the perfect camouflage. Their bellies are covered with these tiny light-producing organs, and they can adjust the brightness to perfectly match the light from the surface, effectively erasing their own shadow. It is a literal invisibility cloak. All of these strategies are incredible on their own, but they also make you step back and ask a bigger question. Making light is clearly a complicated trick, so how did it end up being so common all over the planet? Well, the answer is just astonishing. Bioluminescence didn't just evolve one time. It has evolved independently at least 40 different times. Some scientists think it could be as many as 100. That means fish and insects and fungi and bacteria, all these completely unrelated groups, figured out how to make light all on their own. That's a huge sign of just how useful this ability is.
So, why? I mean, what kind of pressure is so powerful that it made evolution come up with the exact same solution over and over and over again in completely different animals?
The answer is all about where most of life on Earth actually lives, the deep ocean. Most of our planet's living space is deep water. And once you go down a few hundred feet, the sunlight just fades away. You enter a world of permanent, total darkness. And in an environment like that, the power to create your own light isn't just an advantage, it's a resolution. And this is the statistic that really puts everything into perspective. We tend to think of glowing creatures as being super rare and exotic. But in the deep ocean, it's the other way around. More than 3/4 of all the animals down there can make their own light. In the largest single habitat on Earth, glowing is the rule, not the exception. So, as we start to wrap this up, let's pull all these threads together. What does all this glowing really mean? It's like a universal toolkit for surviving in the dark. It's a way to find food, it's a way to avoid becoming food, it's a way to communicate and find a mate, and amazingly, it's even a way to hide in plain sight. It is an entire language written in light. So in the end, what looks like a simple chemical trick is actually one of the most powerful forces in evolution. It takes the single biggest challenge of life in the deep sea, the total lack of light, and it turns it into a world of opportunity. It's just a beautiful reminder that even in the darkest, most extreme corners of our own planet, life doesn't just find a way to survive. It finds a way to create its own light.